Example 1, finding nth roots. Find indicated real nth root or roots of a. So we have letter A, n equals 3 and a equals negative 27. So the index is the 3, so we can write that as 3 rooted negative 27. All right, so since the index is 3, it's an odd number, so the negative 27 has one real cube root. And if we come over here back to our table, we see that to get to 27, we know that goes with a 3. So we know that 3 to the third power would get me 27. But in this case, because we're multiplying by 3 numbers, we're going to need a negative 3 to get us that negative 27. So what that means is a negative 3 times a negative 3 times a negative 3 would get me a negative 27. All right, so the cube root of negative 27 is a negative 3 as our answer. On to B. So this time they're looking for the fourth root of 16. So we write that as 4 root 16. And on our table, we can clearly see there is no fourth root column here. So what we're going to do is we're going to figure out what would multiply to get the next one. So here we had times 2 times 2 times 2 would get me 16. So I can see here times 2, that would be the fourth one over. So that means that my answer should be 2 to the fourth power should get me 16. So if we write that out, 2 times 2 times 2 times 2, does it get me 16? Yes, it does get me 16. So the index is 4, and it's an even number, and it's greater than 0. So 16 has two real fourth roots. 2 to the fourth equals 16, and negative 2 to the fourth would also be 16. So if I multiply that one out, all the negatives would end up canceling out, giving me 16 equals 16 as two positive numbers. So the fourth root of 16 would be negative 2 and a positive 2 for my answer. Example 2, evaluating nth root expressions. Evaluate each expression. So we'll start with A. We have the cube root of a negative 8. Okay, so since we know that the 3, the index, is an odd number, there's only one answer for it. And since we know the number is a negative 8, it has to be a negative number. So we come over to our cube table, and we see the 8. We know it's a 2, so we know our answer is going to end up being negative 2 multiplied 3 different times will give me that negative 8. All right, so if we break this down, the cube root of a negative 8 would just be a negative 2 as our answer. All right, so the difference of A and B, if we look at it, is where that negative actually is. So the cube root of a negative 8 is different than the negative of the cube root. Well, this is just saying what's the cube root of 8, which we know is already a 2. In this case, it's a positive 2, so we know that this is true. 2 times 2 times 2 inside our root would end up giving me that cube root of 8. All right, so when I break this down, this ends up being a negative, and the cube root of 8 would be one of those 2's. So now the negative's out front, and now it gets applied to the 2 itself, giving my answer as a negative 2 also. Kind of tricky, but you just got to make sure you always pay attention to where that negative is. All right, on to C. C has 16 to the 1/4. All right, so what that means is this is the fourth root of 16. That's how you write that when you're seeing that fraction that pops up behind the whole number. So what four numbers would multiply to get 16? Well, I know if I extend this row, I would end up getting 16 again if I multiply by another 2. So I know I could easily write this 16 renumbered as 4 2's when multiplied together would get me that 16. And since all I need is one of those, my answer would just be 2. All right, now D, it's a little bit more on the confusing side because we see the 1/4 here. It's the same exact one before, but there is a negative here, and that kind of causes problems. So if we rewrite this with a negative 16 in there, there's a problem because you're looking for the fourth root that's negative. And even if I put in negative 2 4 different times, that's only going to get me a positive answer. So this is not able to happen. All right, so a negative 16 to the 1/4 is not a real number because there is no real number that can be multiplied by itself 4 times to produce that negative 16. Example 3, evaluating expressions with rational exponents. So here we have evaluate A, which is 16 to 3/4, and 27 to 4/3. Okay, so here we have 16, and we're going to take that rational exponent here and we're going to break them up using our power of power property, which basically says if I have the 3/4, what I'm going to change that to is 16 and 1/4 times 3/1, or in reality it's just 1/4 times 3. Okay, so we just broke that fraction apart, and what that means now is that we're going to take this part of it using our power of power property. So now we're looking for the fourth, or the fourth root of 16, and we're going to cube that. So we know from our chart over here we have 16 is when we multiplied by 2, several other problems. So we know that 2 is going to end up being that root. We have 4, 2 times 2 times 2 times 2 cubed. And so one of those roots would be 2. And now we would cube it. So that would just be 2 times 2 times 2, which gets us 8 as our answer. All right, on to the next one. So here we have a 27 to the 4/3, and we're going to break that up using our power property, giving us 27, and we're going to have that denominator first times that 4/1. Rewrite it again as 27 and 1/3 to the 4th. All right, so now we have the cube root of 27 to the 4th power. So we know that 27 is an easy one because it goes all the way back to 3. So we can rewrite this now as just 3 to the 4th. All right, so let's just write that out. So 3 times 3 times 3 times 3. And 3 times 3 is 9 times 3 times 3. So 9 times 3 is 27 times 3. And that gets me 81 as an answer. So the trick here is to take that exponent and break them apart using that denominator, that 1/4 for the first one, times 3, and the second one be 1/3 times the 4.